Hi students, so today we will be solving this particular problem, which is nothing but integration of sine x divided by root over of 1 plus sine x into dx. Okay, now first what we have to do is simply add and subtract a 1 in the numerator, and then finally we will arrive in this, right? Next, all of these things have been explained before, like what if I forcefully induce a plus 1, then I have to simply neutralize by putting a minus 1, so that ultimately we have a 0. 1 minus 1 is 0, and we will only be left with sine x, which is actually the original question. Okay, now what is the importance of the manipulation? Like, why did we do this manipulation? You will understand it in this particular step. Now, as you know that, say you have you have 2, okay? So can I not write this 2 as a root 2 into root 2? Can I not write it? Yes, definitely I can, because root 2 into root 2 gives us a 2, right? Similarly, root a into root a gives us an a. So 2 roots gives us that number itself, okay? Just the root gets removed. Similarly, here, can I not write this? First we will separate it, okay? First we will separate it. So I am separating it for more convenience, like, so that the problem looks a bit more simplified. It is not mandatory for anyone to separate it, but separating will help you a lot. Initially you might not understand its implication, but later you will realize that if all things are clubbed together, you won't be able to solve the problem. Okay, so now I can write this as 1 divided by root over of 1 plus sine x into dx. I hope you understood what I did. I just separated it, okay? 1 plus sine x divided by this root over part minus of 1 by root over part. All right. Next, what we have to do here is, as I told you about this particular thing, if 2 can be written as root 2 into root 2, then can I not write 1 plus sine x as root over of 1 plus sine x into root over of 1 plus sine x? I can write it, right? Because ultimately the two roots, when multiplied together, of course it has to have the similar element inside. So when such two similar elements with a root are multiplied together, we get the element itself, of course without the root. All right, and in the denominator we had a root over of sine x, 1 plus sine x, right? So one of these will get cancelled, okay, and so we will be left with a root over of 1 plus sine x in the numerator. So integration of root over of 1 plus sine x into dx minus integration of 1 by root over of 1 plus sine x into dx, right? Now, even in the previous problems, I showed you that with sine x, it is, I won't say it's not possible, but with sine x, we haven't really solved integration based problems, right? What we did for convenience is we transformed this sine x into cos x, which can easily be done, because I told you before also there is a trigonometric formula which you actually study even in your 9th and 10th grade actually, and that is, you can write sine theta as cos of 90 minus theta, right? And here theta is x, all right? So this will be cos of 90 minus x. And to be more exact, 90 is actually written as pi by 2 minus x, okay? Now, so we will now get down. We will, in place of sine x, all right, we will transform this entire sine x, and in place of sin x we will replace it with a cos of pi by 2 minus x. So what we will be getting in that place, we will be getting root over of 1 plus cos of pi by 2 minus x, right, and into dx, and here what we will be getting is similar thing, 1 by root over of 1 plus cos of pi by 2 minus x. This is the thing that we will be finally getting, okay. And then what next? Can you see we have a particular formula here, the formula which we essentially deal in trigonometric sub-multiple angles, which we deal with actually in our 11th grade. But in case you are not aware, I have discussed it with this same formula with you before also, that 1 plus cos theta, right, 1 plus cos theta is nothing but, you can write it as 2 cos square theta by 2, okay. So here we have, in place of theta, okay, first let me express it in theta only so that you don't get confused. 1 plus cos theta can be written as 2 cos square theta by 2, okay. If it would have been 1 plus cos 2 theta, then you would have written 2 cos square theta. But here it is 1 plus cos theta, so you have to write 2 cos square theta by 2. Alright, now in place of theta here, what we have is pi by 2 minus x, right? So here also this theta will get replaced by pi by 2 minus x, or simply this entire thing will actually be divided by 2. So ultimately what we will be getting, nothing but 2 cos square will remain as it is, and in place of theta by 2 you just have to halve the angle which is given. So pi by 2 will become pi by 4 because you are further dividing it by 2, alright, like say pi by 2 is given. So if you further divide this thing by 2, what will you be getting? Pi by 2 into 2, which is nothing but pi by 4, right? So here also you will be getting 2 cos square pi by 4, alright, minus, in the place of x also will get halved, you will get pi by 4 minus x by 2. You will have to replace this entire thing here. Alright, so what will you be getting inside of the bracket? You will be left with 2 cos square theta by 2, which is nothing but pi by 4 minus x by 2, and this will be dx, and here also you have to repeat the same thing. It will be root over of 2 cos square pi by 4 minus x by 2, alright, into dx. Is it clear? Well, next what we will be doing is we will be taking this root 2 out of the thing. So bring this root 2 out, alright, and the rest of the part, this cos square part, when you bring outside of the root, what will happen? It will become cos of pi by 4 minus x by 2, right, into dx. Is it clear? I hope you understood it, because if it would have been 4 in place of 2, then 2 would have come out, just 2 would have come out. But since only 2 is here, alright, so root 2 it has to come out, okay. So now that we have come here, similarly here what you have to do, same thing, you will get the same thing in the denominator, okay. So you will get basically you will get a root 2 in the denominator, which I can write outside of the integration sign for more convenience, and in the denominator we will be left with this, alright, into dx. Is that clear? Now next what we will be doing here, essentially we have a root 2. So okay, now in this step before integration we can do a simple manipulation which will help us a lot, actually get up a direct formula here. So I can write this 1 by cos theta, or whatever angle is given to you, as sec theta, you know, from the very basic formulas of trigonometry. All right. Now that we have come here, it is an easy problem, because now you just have to apply the formula directly and solve the question. So root 2 will remain as it is. In place of integration cos theta into dx, we will have sine theta, which is nothing but theta is like this. And in the denominator, we will have to place the coefficient of x which is given in the problem, that is minus half. I have already discussed and told you about this so many times before, and even now I am repeating it, that when you don't have such straightforward angles like sin x and cos x, when you have something multiplied or divided with that particular angle, you have to ensure that you put that particular extra in this denominator. All right. Even though the straightforward formula for integration of cos x dx is sin x plus c, but you have to also ensure that here we have a minus half as coefficient of x, so that has to come in the denominator. Such questions of integration of f of ax plus b form dx form we have solved before. All right, many problems we have solved, and I hope you understand what I try to what I try to basically imply by this. Okay, so next what you will be getting here, you will have a 1 by root 2 as it is, and sec of theta dx, how sec of x, integration of sec x dx, how do you what is the formula? We have done it before. It is nothing but log of sec pi by 4 minus x by 2 plus tan of pi by 4 minus x by 2. All right. Mod sign is something that you have to remember. Now here again you need to put a minus half. All right. Next, ultimately what we will be getting, now this 2 will come in in the numerator, because I hope you know that minus root 2 divided by half is nothing but root 2 into 2 by 1, right, which is nothing but minus 2 root 2. All right, so here we will be having minus 2 root 2, and this particular thing will be as it is. Okay, just place it here, minus of, again here we have 1 by root 2 divided by half, right? So we will be getting 1 by root 2 into 2 by 1, which is yes, so what we will be having here, as I told you, 2 can be written as root 2 into root 2. Okay, so one of the root 2's will get cancelled and we will be left with a root 2 here. Okay, and it will become plus. Okay, this will no longer be a minus, it will remain a plus. Okay, and then you will put this entire thing including the plus c here. All right, I'm not writing it anymore because it's no longer required. All right, but you please write it down. Okay, now this problem was not like a very difficult problem or something that you can't solve. It's just a simple trick of, you know, adding and subtracting with a number, which helps us solve the entire problem, and of course some basic application of trigonometric formulas that is also very significant to solving this particular problem. I hope you understood this problem. I just broke down the problem into the maximum level possible. Okay, I also showed you things like these which it's expected that you would know, but still since I told you that I'd be teaching everything from scratch as much as possible, I'm trying to do that. I'm trying to abide by that, and I hope you're understanding whatever is being taught. So if you really enjoyed this video and did gain some profit out of it, then please don't forget to like, share, subscribe, and hit the notification bell icon for more of such exciting content. See you in the next video. All right. Thank you so much.